Hello, in our today's video, today I will try to solve the hard problem, which is the integral from 0 to pi over 2 sine to the power 11x dx. In order to solve this problem, I used here substitution method. Now, before I go to the substitution method, I tried to split sine to the power 11x to sine to the power 10x and sine x. Let me show you. The integral from 0 to pi over 2, I split it sine to the power 10x sine x dx. And after this step, I decided to write this way: the integral from 0 to pi over 2, 1 minus cosine squared x to the power 5 sine x dx. You can ask me, where did it come from? We know that sine squared x plus cosine squared x is equal to 1, and I wrote sine squared x as 1 minus cosine squared x, like that. Let me erase this equality. So now I want to apply substitution method. U equals cosine x. I will actually substitute cosine x here. So in order to find that, we have to take the first derivative of cosine x, which will give us du minus sine x and dx. So I will put actually du minus sine x into dx in order to get rid of sine x. Let me show you. The integral from 0 to pi over 2, 1 minus u squared to the power 5, and here sine x du divided by minus sine x. We simplify that and get here integral from 0 to pi over 2 minus negative sign must be put here, minus u squared to the power du. So I decided to open the parentheses here, and we get such an equation. So minus integral from 0 to pi over 2, 1 minus 5 u squared plus 10 u to the power 4 minus 10 u to the power 6, and we also get here plus 5u to the power 8 minus, and we have to write here minus u to the power 10. I want to erase this space, this area, in order to get much space. So we have to find out the antiderivatives of this equation, and it will be I want to get rid of pi over 2 and 0. I want to write 1 and 0. I want to write actually in this manner: from 0 to 1, from 1 to 0, and 1 minus 5 u to the squared plus 10 u to the square, and 10 u to the power 6 plus 5 u to the power 8 minus u to the power 10. You can ask me why I wrote here 0 and 1, because cosine p over 2 is equal to 0, and cosine 0 is equal to 1. And let me erase. So now we have to find the antiderivative of this equation. It will give us it will give us u minus 5 u to the power 3 divided by 3 plus 10 u to the power 5 divided by 5, 10 minus u to the power 7 divided by 7 plus 5 u to the power 9 divided by 9 minus u to the power 11 divided by 11. 1 and 0. Let me erase this place. And we have to put 1 into this u, into this equation. Actually, we don't have to put 0 because the whole equation will give us 0. I put here sign square, equality sign, and write so 1 minus 5 over 3 plus 2 minus 10 over 7 plus 5 over 9 minus 1 over 11. And we calculate this fraction. 3 minus 5 over 3 minus 10 over 7 plus 5 over 9 minus 1 over 11. So 4 over 3 minus 10 over 7 plus 5 over 9 minus 1 over 11. And yes, so we combine these fractions together and get 12 plus 5, and here 77, 110 minus 110 plus 7 equals, let me erase this place. After this step, we can write so 17 over 9 minus 117 divided by 77, and here we write 693, and 77 multiplied by 17 minus 9 multiplied by 117, we get here so 1053. I'm really sorry. So after some calculations, we will get here 256 divided by 693 equals approximately it will be 0.36, and that's our answer. So as you can see, in our today's hard problem, I applied substitution method and applied some basic trigonometric knowledge, trigonometric equalities, and that's it. If you liked my video, leave a comment, and thank you for watching. See you next time.